Hi everyone, today we're looking at statistics and specifically population sampling. There's going to be a lot of keywords, so I've left them all in green so you know which of the words are important and for you to write them down. First of all, we're going to look at population sampling. What does that mean? Population means we're looking at the entire group. So if we're talking about your family, that means every member of your family. If we're talking about your country, then every citizen or every person in the country. Now that is very expensive to ask or to view or to analyze. So a lot of times we're looking at a smaller portion of this population. And we use a smaller portion to predict what the bigger population thinks. Now, if we did look at the whole population and ask them questions, this is called a census. So every member of the population gives us feedback. For example, in Australia, we have a census every 5 years. A poll or a survey is the same process, so you collect data, but this time you're collecting it from a smaller portion of the population. So the census is to collect population statistics, so numbers and analyzing everybody, whereas the poll survey is collecting data under sample statistics, looking at a smaller amount of numbers. And we do that because it costs a lot to run a census. And so we use the sample statistic because it's a lot cheaper to predict the population statistics. And sometimes we can do experiments as well. That's when we collect data by measuring, counting, or assigning labels. Let's look at a few examples and see which category they belong to. Let's say I wanted to find the average height of students at a school, and I measured the height of a few students from each year level. Which of the 3 categories do you think it belongs to? Well, I've measured the students, so that is experimental data. What about if I wanted to find the same thing, but this time I surveyed all the students at the school? That's census, when I ask every member of the population. Now take note that in the questions that I'm writing, I've made it very clear that there's a goal and I'm collecting the data in the second sentence. Sometimes the sentences in questions are all jumbled up, so you have to decipher what am I looking for and how am I doing it. What about if I want to find the average height of students at the school, and this time I ask just one class? If I ask just one class, then the survey I did is sample statistics, or I've conducted a survey, not a census. What about if I survey the first 20 customers at a bubble tea opening of a new store to see whether the customers were happy or not? Well, if I ask the first 20 customers, that's again a sample, so that is taking a survey or sample statistics. What about I survey all the customers that walk in through that door that day? That's looking at the whole population, so that's census or population statistics. Now, how would I do an experiment? Maybe I could tell you how many cups left behind were empty or full. Then if I'm checking and I'm counting, if I'm counting, then it is experimental statistics. Let's have a look at the types of data that I could be collecting. They could be categorical or numerical, as in words or numbers. Now, with numerical, you might have seen discrete data, which is values that can be counted, and continuous data, values that are measured. So with counting things, it could be how many times did you go to the bathroom today, or how many sit-ups can you do? Whereas things that can be measured could be how long is your pencil, or how heavy is your book, or how long can you run for? So things that have measurements. Now, sometimes you might have seen definitions as discrete, having no decimal, and continuous, having decimals, but that's not quite right. When we talk about discrete, are things that have to go to the next thing that you're counting. One very good example to distinguish between the two is your shoe size versus how long is your foot. If you're measuring your foot, how long is your foot, that's definitely continuous data, because when you measure, you can be as accurate as many decimal points as you want. Whereas when you're wearing a shoe size, it can be 37.5, for example, in the UK or US. So there's 0.5, there's a decimal. So it might sound not discrete, but it is discrete because you can't have 37.4 or 37.6. They don't exist. So that is an exception. Most of the time, discrete data have whole numbers, but that also helps us distinguish between the words discrete and continuous. So discrete are things that you can count, or it goes to the next value, and continuous are things that you measure. With categorical data, we have nominal, so words that are just different subjects with nothing but random categories, or ordinal, categories that you can put in order, like how happy are you today, from really sad to really happy, or how thirsty are you right now, very little to a lot. So things with order. Or how well did you do in your assignment, you got an outstanding or a satisfactory. So these are ordinal data. So they have words, but they can be put in order. So looking from left to right, I have made them so that it's from, to me, most disorganized, like just random words, to you can put them in order, to you can count them, but they're mostly whole numbers, to you can be very specific and measure to many decimal points if you wanted to. So let's look at what they can do. Now, if you are looking at nominal or ordinal data, so just categories, you can only look at what's most popular, what's chosen the most, and that is the mode. When you're looking at numerical data, of course you can look at what was chosen the most, like the most popular shoe size was size 7, for example, so 7. But you can also, because they're numbers, you can also work out the median, which is the middle number, the mean, which is adding up all the numbers and dividing by how many numbers there are, and also the range. So I could look at the numbers scores for the last test and have a look at the range. If one class had between only 70 to 80% and the other class had between 10 and 90%, then one class is more consistent than the other, the range. So I'm just going to show you that, I'm just going to highlight that categorical data can only find a mode, whereas numerical you can find lots of different things. So how do we collect the data? What does it look like? In all these 4 categories, we can use frequency tables. For nominal data, it could be asking our friends what their favorite fruits are. So you could collect it in a tally. And for ordinal data, it could be how hard is it to save money? Very to not sure how to save money at all. With discrete data, it could be the scores you got playing a game between 1 and 5, which are numbers. And with continuous data, it could look like that, where the categories these times are in groups. Let's have a look at how to sketch the data that we get from these 4 different types of categories. Have a look at the graph behind me. Now, the categories are words, so we know it's categorical data and not numerical. But are they in order? Not really. These are just different funny words that I put together. There is no from least to most. So this is not ordinal, this is nominal. And in nominal and ordinal, we often use bar graph because we're just looking at which one is the most. And we can also use pie chart to have a look at the percentage of each of them. Whereas with numerical data, I should have put a line here, we can use bar graph, or also known as column graphs, or we can use histograms. And a good way to remember which one belongs to which one is the continuous one has histogram, a word that continues. It has no gaps in between each of those columns. Whereas discrete data, like all the numbers have gaps in between them, it's not continuous. Even the name to call the graphs have a gap in between them. Column, graph, bar, graph. They have the gap in between the name as well. We could also use box and whisker plots because there's mean, median, mode, and then we can go into quartiles later on as well. Let's see if you understood. Let's have a look at a few examples. I've done a Year 9 survey where I randomly pick different topics and I ask them, hey, can you just pick which one relates to you? Which one did you do today? So these have no order at all and they're words, so they belong in nominal data. I've also asked my students, hey, did you drink enough water today? And their answers were in words, so it's categorical, and it was between not at all to Yes, I've definitely drank enough water today. So this is ordinal data. Then I've asked the kids, can you plank and how long can you plank for? Now they had to measure how long they can plank for. This is continuous data. And then I've asked them, how many push-ups can you do? They had to count the push-ups. So this is discrete data. So now that we've had a look at the different types of data that we can collect, we're going to look at how we collect the data. So we can have random selections where elements have equal chance of being selected, or stratified selection where different groups are represented equally, and bias where it's not fair and my data is pretty much useless. Let's refer to the examples we did before and try to put them in these categories. Now there were a lot of examples, so I'm going to delete the 2 that are not relevant, and we're going to look at these. So finding the average height of a student at a school, and we measured the height of a few students in each year level. So in each year level. So if I went and got a few students from each year level is fairly represented. So this is called stratified selection. But if I wanted to find the average height of students and I only asked 8B3, so a pretty young student, not the year 12, then this is not very fair at all. So we call this very biased. Another way to ask students at a school for their height and be fair is to pick randomly. Now, how do I get a random selection? Well, what I could do is number all the students in the school and use a random number generator. It's like picking out of a hat numbers and asking those students how tall they are. So that'll be a random selection. And remember the question about the new opening of a bubble tea store? Now, if we tallied how many cups left behind, would that be stratified or random or biased? That will be random because we don't know who left the cups behind. Probably lazy people. And if we survey the first 20 customers that came in, well, that is definitely biased. They're probably very keen to come in and try it. Maybe their store related to the store or their family friends, so they're probably biased. So just to recap, the way we collect data could be random if you don't select people from one group and just randomly spread it out. Whereas stratified data is when each group has equal opportunity to represent themselves. For example, if we ask, is pizza the best food ever? And we only ask Italians, then that will be biased opinion. We'll have to give the survey to different nationalities so that we get stratified selection. So different groups have a voice. So I hope you understood all the keywords today. So there were what types of data they are and how we collect the data. So have a look at the green keywords and watch this again. And lastly, how do we randomize things? There's a calculator video that I'm going to put up where it uses the randint function, which generates random numbers. All right, that's it for me today. Bye.